So in the last example, we were trying to predict how far someone might live from where they work, distance from home, that was our dependent variable, with age as our independent variable. So we put that into a simple linear regression output. Now, often we usually have hypotheses that more than one thing is predicting or affecting what it is that we're focusing on. So you will always have just one dependent variable, meaning the one that depends on the other things in this kind of setup, but you could have multiple independent variables, meaning the things that can change, but you think might have an effect on the dependent variable. So let's say that we wanted to do that with our example. So instead of using only age to predict distance from home, let's say that we have a hypothesis that not only is it how old someone might be, but it's also how much they make per hour. So maybe we think it's a combination of how much money someone makes and their age that predicts how close they may live to the place that they work. Now, again, this is probably a terrible model because there's not a lot of reason to believe that, but the point of this is just to show you how to do regression in Excel. So given that both age and hourly rate are what we'd call continuous variables, meaning they just kind of go up and up and up and can get bigger, we can use them to predict distance from home, which is also a continuous variable. Now, assuming you already have the data analysis toolpack included, as I showed in the last video, you can use that to run your regression. But your data has to be set up in a certain way. So right now, all of our variables are really far from each other. I have an independent or X variable of age here in column A. I have my dependent or Y variable here in column F. And then that one around hourly pay was all the way over here in column M for hourly rates. So if I want to use these together in a multiple regression, I have to have my independent variables that I want to use next to each other in the file. Because I'll show you in a moment, but Excel is going to ask you to select all of your independent variables together as one data set. So this hourly rate needs to be next to age if I want to use the two of them together. Now there's a lot of different ways you can clean up and set up your file. I'm just going to do a very easy one, though probably one that has issues with human error, but I inserted a new column. I'm going to go over to my hourly rate column, which jumped to column N now because I inserted a new column. I'm just going to go ahead and copy it, and I'm going to paste it again over here. Now, yes, that means I now have two columns that both say hourly rate with the same data, and there's all sorts of different things that you might want to do better from a data management perspective, but I'm going for quick here. So now age and hourly rate are next to each other. Distance from home does not need to be right next to the other two because it's the one I'm going to have all by itself. It's my Y variable. The thing that is important though is your rows have to still be connected, meaning that this age should align to the same person who has this hourly rate and the same person who has this distance from home. So think about this as a file that might be about you. You know, you'd want your age, your hourly rate, your distance from home all on one line. So that's important to keep it connected. But once you have it all set up, you can go to data analysis and you'll use the same exact regression as we did for simple linear. So it's not a new setup or a new one. We're just going to make a couple tweaks. So once we're in, we need to make sure that it has the data set correct. It still has my work from the last time, which we changed rows. So I can go into the areas where it wants me to select and input my Y, which in our case is distance from home. So I'm going to go ahead and press this little arrow. I'm going to start to select it, but then I just prefer to type in the final number because I know that the last row happens to be 1,471. And so now it has column G, distance from home, and it goes all the way down to the bottom. Now it's asking for my X range. When we did this last time with the simple linear, I just did the column for age. But now that I want to look at both age and hourly rate in predicting distance from home, now when I go to select my data, I'm going to select both columns. This is why they have to be next to each other in the file. And I'm going to get the data that goes all the way from A1 to B1471. This way I can get all of the data in both columns. And again, in my data set here, I have labels, meaning the top row has names. So I need to make sure that's selected or else the math will get wonky. And again, it wants to know, where would you like this output range? So in my last example, I put in the same sheet just to show, but here I'm gonna go ahead and put it in a different worksheet. So rather than being down here, I made a new tab in Excel, and I put the simple linear regression that we did last time in it. So while I am in the regression one, I can still go to a different tab to tell it to put the data over here in another file or another tab. So I'm going to click here because I want to be able to show you side by side what it looked like when we did just one independent variable and what it's going to look like now that we have two independent variables. So I told it to go ahead and go to that tab and put it there. I'm going to ignore the rest of these for now. Again, probably a topic for another video. Okay, and because I selected that new tab, once I pressed the OK button, it gave me the output right where I told it to. And now we can see side by side the output from the last video where we used just the predictor of age to predict what the distance to work from home. But now in this new one, which is starting over here, now we're able to see the values for when we have both age and hourly rate included. So the output that we get is the same in terms of which values you get, though the numbers are going to be different now. We have an additional variable in our model. So our multiple R, which in the last example was just like a correlation, it's a little more complicated now because now it's asking what's the relationship between distance from home and age with hourly rate included. And in this case, it's a 0.03. Now that's bigger than the last time. The last time we had a 0.001. And we can see also that our R square, which is just that multiple R multiplied by itself, is in this case 0.000975. Still a very tiny number, but slightly bigger than the last time. We lost that pesky little E scientific notation that meant that it was super tiny. And so there's also this adjusted R square. Now that is giving you how to think about it in more context in terms of how much error, what your sample size is, and even the kind of direction that your data is heading in this case. So again, a slightly bigger number, it's still tiny, but it's a little bit closer to zero than this one was over here. And that's just because it's a negative, so it's technically bigger, even though it looks like a smaller value. And then the, again, we're going to skip over standard error in concept, but it's an idea of how much issues or error you might have in your model. Observations is just the number of data points that were used, so that's how many basically rows or sets of data. Now in our ANOVA, which again, ANOVA is a whole nother analysis that we will not be able to dive too deep into here, but we can look at whether or not our ANOVA is now significant. This is essentially like a p-value, and it is about half the size of the last one. So it did change quite a bit, and smaller is closer to significance, but this is still considered too big a value. We're typically looking for something smaller than a 0.1 or a 0.05 or a 0.001. So we would still say this is not significant. And we can definitely tell that by going down to look at our coefficients. So just like in the simple linear one, these together make up our definition of the line. So the intercept is where it would start at 0. And then we would know that for each additional year of age, that we would expect distance from home to go down this time by about 0.002. So it's changed. It's not the same exact number that we had over here. So you'll see that the numbers are different. And the reason that it's different, it's still the same data. It's still age and distance from home. But what's different is now it's saying how much would age affect distance from home when considering hourly rate along with it. So this is really not about age alone. This is about age with hourly rate. And that's kind of the power of multiple regression. And then we can see that hourly rate, when included along with age, it's a positive number. So we would say that for each additional dollar, because that happens to be how hourly rates data was set up, for each additional hour, we would expect distance from home to increase by 0.012. That's tiny, but theoretically, maybe you'd say, well, people who get more money per hour might be willing to drive a little further from their home to the office. But the number is very, very small. And we'd still want to look at the p-value associated with each. And in this case, these p-values are not small. If you watched the last video, I joked about how it's like p. You'd like as little of it on you as possible. So these numbers are just much too big. 0.9 and a 0.23, we would say this is not a significant model. This model does not predict the distance from home that a person might live well, if at all. So our finding from here would be that no, even when age and hourly rate are considered together, they are not good predictors or good explainers of how far a person might live from where they work. So hopefully that helped you see how to do multiple linear regression in Excel. Now, any form of linear regression in Excel, is only meant for certain types of data. This really only works on relationships that we assume would fit a straight line. So if we think that it would be, really high at lower ages and then drop down and then really high again at higher ages, that would not be a line relationship. That would look like a U, and you'd want to use a different kind of statistical approach for that. So just understand that these approaches only work for relationships that we believe might go in a line and with data that's set up in a way that's continuous that we could draw a line through. So keep those in mind, but this is how you do it in Excel.